by the end of the sharing, you should be able to achieve, to build something similar to this yourself in the future. So I'm just going to show you something like this. As you can see, I have the ROS core that we mentioned yesterday, the ROS master running, and this is the ROS serial. That later I will teach you how do you install this, how do you set up all this stuff on your own, as well as I have on the left part of here, I have AI running, the AI called YOLO. We can install it. So it is called the YOLO V4, and its purpose is to detect the location of the object in real time through the camera. So as you can see, I have made it so that it can detect the object scissors, and you can see that the scissors is currently at the center of the frame. And if I move it to the right, right or left, I forgot already, the right of the frame, it should be able to determine that it is, wait, let me just, it should be able to know it is at the right part of the frame. And if I move it to the left, it should be able to know that it is at the left parts of the frame, like so. Okay, so what is happening here is that I have connected this ROS to the Arduino, as you can see from the frame. I'm not sure if you can see it. Yeah, you can see that there are 3 LEDs over here. It's a bit laggy because it has an AI detecting of everything. So if I put the scissors at the center of the frame, then the LED at the center, which is the yellow one, it should be blinking. Yeah. Let's give it a time for you to see. Okay, so this is the center, and this is the left part. It should be lighting up the one that is on the left, the red one. Okay, and on the right side, it should blink the green LED. Okay, so you should be able to achieve something like similar to this by the end of this today's training. So yeah, as we discussed yesterday, this is how you can connect a camera to your Arduino while doing something very complex like AI, and you can use AI to control your Arduino. I forgot yesterday who did I ask to answer the questions. If I'm not mistaken, it was um where is he? Okay, I'm sorry I couldn't recall who did I ask to answer that question yesterday, but it's okay. Yeah, this is basically what you can do after you went through today's training. So okay, let's go to the first agenda for today. We said we are going to recap everything from yesterday. Just a quick one. I won't go through very details. As long as you can always rewatch the recording. So okay, so as always, before everything started, I would like to encourage you all to interrupt me at the middle of the sharing. If you have any question, just ask me. Open your mic or type in the chat box and let me know if you have any questions. All right, cool. If you are cool, then just type in the text in the chat box so I can see that you all are okay with that. All right, cool. So, okay. Oh, what the hell? Okay. So yesterday we basically discussed about what is ROS, what basically is ROS, and how do you set up everything, and why do you use ROS, and when do you use ROS. Okay. I'm not going to go through very details for this, at least as long as you already have the general idea of all these 3 things that we discussed yesterday. So I'm just going to recap a little bit. When to use ROS is that when you are trying to do a quick prototyping, whether or not you want to reuse the code from the previous project, or you want to reuse the code from another developers. And the second thing is you want to use the complex sensors like camera or even LiDAR on your robot, but your robot is powered using Arduino. And the third thing is to control the industrial grade actuators like robot arms and many more, lah, including the motors and all that. And as always, this is the general diagram, the general idea that shows the general idea of the ROS. So you have the ROS master, who is the one that is responsible to manage all the communications between the nodes, and the nodes are independently executable program. So you could have a publisher and you can have a subscriber. Every node can be both a publisher and a subscriber. Okay, and they are communicating through a thing called topic. We call ROS topic. Okay, and the form of message, the form of data, the way they are communicating with each other is in the form of message, ROS message. And if you wonder, if you forgot or need another glance of all these simplified visualization, is basically something related, very similar to YouTube, where the ROS master is very similar to the website itself, YouTube, and the publisher can be a YouTuber like PewDiePie, and the ROS topic can be a YouTube channel, and you yourself as the viewers could be the subscriber because you are subscribed to the particular channel, like YouTube channel, and so that you can see what the publishers are publishing, and they are publishing the information in the form of video. Same goes to ROS. Okay, they're in the form of message, in the form of topic, in the form of notes, and the ROS master is the one that is managing all the communication. Cool. So this is basically the recap of yesterday's lessons. If you would like to know more or anything, you can just call me in, PM me, or leave me an email if you have any questions, or you can just rewatch the recording that we recorded yesterday. All right, let's go to the second agenda for today, which is the recap of Unix and CLI command. Okay, so before I go into very, very deep, I would like to do a survey to y'all that how many of you doesn't know what is Unix or CLI? You can just type in the chat box if you didn't know, or you can just raise your hand. Just raise your hand if you don't know, or if you, yeah. I have heard about it, but not clear about it. Sure, it's okay. Okay, so I see there are a few people raised hand that they are not very familiar with CLI or Unix. Then can I assume that most all of you are quite familiar or have heard about it before lah? If you have heard about it or use it before, maybe you can raise your hand or type in the chat box that you have some experience about it. All right. Okay. I'm pretty sure that most of the Airost members have some experience with it because previously Siyuan just had a sharing on it lah. But but I'm still going to go through again because some of you are not very familiar with it. So I'm just going to open up a new terminal. Instead of using Terminator, I'm going to use the normal one, just so you can visualize it and try to sort of relate to it. Okay, let's hide all the chaos behind. Okay, so the first very common things that we usually use, the very common command that we use in Linux, we call those command we call it the Unix, is cd. Because now because when you are doing something in your terminal, you're gonna have to direct or get into a certain folder, or explore the directory inside your computer. So you just want to instead of using the graphical user interface like using your mouse and click on the folders, there are a lot of limitations that you can do with this kind of interface, like using your mouse and keep and the GUI. because you don't have the super user privilege. But on terminal, you have something called the sudo, as I explained yesterday, which is a super user do. So with this command, you can do a lot more than just copy and paste using your graphical user interface. So that is why we need to learn about Unix. So the first command that I'm going to talk about is cd. Cd allows you to enter or leave a certain directory freely throughout the terminal. For example, now you can see that I'm currently in the curly symbol. Curly symbol is basically means that you are currently in the home directory, which is in graphical user interface. You can see something like this. Yesterday we did show about this is the root, and this is your home. And when you click on your user, it should be bring back to home. And this is where the curly I'm not sure what's the actual name for this, but it's curly symbol for this lah. So if you want to let me just prove it to you that it is the home directory. Just type in ls. Okay, so you can see that when you type in ls, you can see pretty much every single folder that is available inside the directory. For example, you have a desktop, documents, download, music, pictures, public, and so on and so forth. Training workspace. Later, I will be teaching you how do you create a workspace. Don't worry. And yeah, so you can see that when you are in the curly line, you're basically inside this particular directory. So what if you want to go into the folder called maybe documents, or maybe if I go to downloads, okay? So if you want to go into somewhere, just type in cd space and type in the name of the folder that you want to go in. And most of the time, you don't need to type in the full name of the folder. As I said yesterday, you can just double tap, just so you can automatically complete the name for you. Or if you don't know what is inside the folder, or there are too many files or folders inside a particular directory, then you should use double tap just to see what are the directory or the folders or files that is available in that particular directory. So in this case, we're just going to go into the download directory. Just press on enter. And can anyone tell me that how do I check what is inside this folder? How do I do that? See, Liang Ming is raising his hand. Okay, ls, correct. So ls, so you can see that I have all these files and folder that is inside my download folder. So pretty easy, pretty straightforward. cd ls, cd ls. Okay. These are the most common command that you're most likely to be using. And one more command that I would like to sort of like share is this make directory. This is to allow you to basically create a folder inside this particular directory. Let's say I want to create a folder inside the download folder. So I'm just going to just make directory. You can just memorize it like this, make directory. And just so just to make sure that everything works fine, I'm just going to just -p. I will explain what is this. So you can just type in, I don't know, like give your file a name. They say, I will say just call it tutorial folder. So I'm just going to just press enter. And now see what happens if I type in ls. So you can see that there is a new folder exists inside this particular directory. So you can see that it automatically exists over here. So what you just did was just basically just right click over here and create a new folder and name it, I don't know, hi. It's the same thing. It's a fancy way to do it, but trust me, you're going to need it in the future, because if you're running your Ubuntu or Linux on a single board computer like Raspberry Pi or Jetson Nano, where you most likely you're going to install a Ubuntu server instead of a Ubuntu desktop. So How many of you have realized that when you were doing the prerequisite for yesterday's lesson, when I asked you to download the Ubuntu images from the Ubuntu website, but I received a question that some of you didn't know that which one to download, whether it is the Ubuntu desktop or the Ubuntu server. Did anyone notice about that? Okay, so it's okay. Let me just go into uh, uh, that website. Let's say you can see that. So when you go into this like particular website, you can see that last time you will download this desktop image for this. This is the one that you are using right now, where you have all the desktop interface, you have all the graphical interface. But if you are using the server version, then you most likely you don't even have a mouse. Everything on the screen will be just your terminal. So in that case, you're going to need to use this Unix and CLI just to go to a certain directory or create a few folder or delete a few folder. But we're not going to do that because for this training, because I mean you have the real estate of using the graphical interface. So why bother, right? So this is just something to for you to learn, which is the CLI and the Unix lah, the most basic ones, and the commands that we most likely will be using throughout this training. And yeah, I think that's these are the three main commands that I'm going to share for today. As long as you can get the idea of doing this. Okay. So far, is there any questions before we proceed? If no, you can just type in the chat that you don't have any questions, and we shall proceed to the next session. Jillian says nope. How about the others? So far, no. Great. Okay, good. All right. Seems like majority of you are okay with it. Then we shall straight go to the ROS part already. Since now we already used up 20 minutes. Just so you know that today for today trainings, because we have quite a lot to cover, so we'll only have one 10 minute session of break for you to go for a bio break or anything that you want to do, to take a breath or take a breath to digest. Okay, and you may ask any questions when we are taking the rest lah. So okay, great. Now can anyone just tell me that now if we want to go into the next session, which is creating your ROS workspace and all that, which website should I go? Who is your friend? Can everyone type in the chat box? Is this session recorded? Listening. Yes. Okay. So yeah, it is recorded. Okay. So anyway, so back to the questions. Can anyone tell me that which website is your best friend to look for information that is related to ROS? ROS Wiki. Yes, perfect. So let's go ahead and go type in ROS Wiki. Actually, I already inside there, but so let's go to documentations. Go ahead and click on tutorial, and you can see that you just click on the first link, which is installing and configuring your environment. Tap on it, and you should be greeted with in this interface. Okay, so let's take a look. So for the top 1 and 2, basically yesterday you have gone through. Yesterday we have shown why do you source your this certain directory, because you want to you want to have the luxury of when you open a new tab, you can straight away use type in anything that is related to any commands that is related to ROS. Okay, so yeah, you can just skip to the third one. Let's see, where is it? Where is it? Oh, it was there. Okay, so we're starting at the third topics over here, which is creating your ROS workspace. So some of you may be asking, what is a ROS workspace? So let me show you that just now when I list down everything that every folder that is available inside my home directory, you may see that there is a new folder that could be different from yours. That you don't have this training WS. WS stands for workspace. This is basically how I name it lah. And yeah, and for a ROS workspace, it's not compulsory for you to use a Catkin workspace name. Okay, but for beginner, I would recommend you to go with this, because if you are looking for any kind of online tutorial, they are going to use this name for their workspace. However, for me, later I will teach you how do you create your own workspace and why do you create a separate workspace for a different project. Oh, I just give out the answer. Anyway, yeah. So let's go ahead and go for use copy up the first command over here. B, very easy. Just paste it. Make sure that you are in the home directory. Yeah. Make sure you're in the home directory and paste it over here. Can anyone tell me that what is happening over here? When I press on enter on this command, can anyone tell me what is happening over here? Just briefly explain, or you can open up your mic if you want. If no one's want to answer, I'm going to call out someone. 3, 2, 1. All right, let's see who do we have today. We're going with Eunice Ling. Eunice Ling? Eunice, am I pronouncing it correctly? Eunice Ling, are you there? Hello? Eunice Ling? Maybe he or she is not here. Anyway, maybe we can go for Jia Sheng. Eng. Are you there?
Yes.
Yes, Jia Sheng. Yes, how are you?
Yeah, fine.
Yeah. So can you briefly explain what is happening over here if I were to press on enter on this
Uh,
command?
create a folder called catkin underscore ws, and then create a source folder, src folder inside the catkin ws.
Yes, correct. Perfect. So yeah, thanks, Jason. Okay, so yeah, this if I press on enter, this is exactly what will happen. And you may be may wonder why do I put this minus p as I just did just now also. I just put a minus p. So this is actually a special command for this particular command make directory. This minus p is to make sure that it is included all the necessary directory before the home directory. Okay, before the home directory. Let's say you are in, I don't know, you are not inside the let's say you are not inside the home directory, and you sort of like you want to create oh no, this is I don't want to mess with the root of folder. Let's go back to here. But if I were to put there, and maybe I didn't put minus p, and I straight away just catkin catkin workspace, and I just create a source. This is not a very good example, but let me just create this. Okay, I'll just create this catkin workspace. So if I put to press enter, surely you should create a new folder called the Catkin workspace over here. But look what happened if I were to make directory and I call it the source. I put Catkin workspace /source. uh, oh, this will do. This will also do the same thing. But okay, I don't know how to visualize it. What is the purpose of the minus p? But the minus p is basically because you know that before the home directory, there are a lot more directory. As you can see from here, you have in the root directory, and you have to go back to home, and you have the username. Then only you are in the home directory. But if you didn't put the minus p in some cases, then the directory that is before the current directory that you are in is not going to be included. But in this case, it's basically foolproof lah. It's great. So we're just going to just you can just press enter for the command that you just copy from the ROS wiki. But from my case, just now I already created the Catkin workspace, so I'm just going to create a new directory, which is the source inside of the Catkin workspace. It's basically the same thing lah. Or you can just right-click new folder, call it Catkin workspace, and create another folder called source inside of the Catkin workspace. It's the same thing, okay? But you just want to practice using terminal to do the same thing, okay? So what's next? What's next is that you're going to new cd inside the control the Catkin workspace, okay? The Catkin workspace. Now I'm already inside it, but if I were to go back and go, if I want to go in, I just cd cat double tap. Okay, double tap. I should go to the Catkin workspace, press enter. I should be inside the directory. Oh yeah, this one I didn't explain that how when you go into a certain directory, but you want to go back, right? So there are a few ways that you can do. First, you can just cd double dot and press enter. You should go back one folder before the current directory, and or you can just cd and type in the whatever the directory that you want to go. Let's say I want to go to the home directory, and I can just cd home. Or if I want to go to the root directory, it's cd slash. So this allows me to go into the root directory. If I were to press ls, then I should be seeing every folder that is inside the root folder. As you can see, they are similar for over here. Okay, so you have the bin, the CD-ROM, the etc, etc. Okay, so let's go back. So before you run to before you execute the next command, which is the catkin make, please make sure that you are inside the Catkin workspace directory. Okay, please make sure you are inside here, and only you paste in the command. Okay, so this is Catkin make. You may wonder, like, what exactly is Catkin make? So for those who are working or have been typing or writing program in C programming, and you were to compile your C code, but usually you have an ID to do that, and or even like you compile it for one folder for one file only. But for CatkinMake, it's going to do a lot more. It's sort of like a CMake to you for you. If you wonder what is CatkinMake, you can always go to this web page over here. You will explain everything. So CatkinMake is a special version of a CMake for in ROS that it will basically also do this part for you. As you can see, you will cd in, make sure that you are inside the Catkin workspace. It will cd into the source, create initialize the Catkin workspace, cd dot dot to go back one directory, make the directory called build, cd build, and cmake everything, and make. Okay, so this is the things that if you don't want to use the command catkin make, you can also manually do this. Up to you. Okay, so let's go ahead and press enter on. Before we press enter, let's ls and see. We inside the Catkin workspace, we only have the source folder, which is the src. So if I were to just go into Catkin make, if I press enter, it should take some time. just maybe sometimes it will take only a few seconds lah, because your workspace is new. Okay, so you should be done right by now. And if you type in ls, you should be seeing that there are new folders coming in, which is the build folder, the develop folder. So if you were to go into the Catking workspace right now, you should seeing this. Okay. Okay. So great, awesome. Okay, now what's the next step? Let's go back. Now, yesterday, we did go through a certain setup when you have to source your root, OPT, ROS, noetic, and setup bash, right? Can everyone remember about this, or you need more explanation on this setup.bash or sourcing your ROS package direct path? No. All right. So same thing. If you were to echo your current ROS package path, you can see that you already included the OPT ROS noetic share directory. So now, because you have already created a new workspace, which is called the Catking workspace, and in the future, all your new packages and code and nodes are going to put inside of this source folder. Okay, you are going to put it inside here. So not right now, your ROS only recognize that any packages or nodes that are stored inside here, but they didn't know that you have a new workspace, which is the Catking workspace as shown over here. So what you're going to do is you're going to type in source. Okay, and you can see we have a folder called devel. Just type in devel, double tap. You can see that you have all sorts of stuff. And you can notice that there is a similarity comparing to the command that we have previously. Let me just open it up, the files. Okay, remember we have a bash RC over here. And at the very bottom of the file, you can see that yesterday you have already sourced the OPT ROS noetic setup.bash over here. Can everyone see it properly? Because I think it could be quite small. Is it too small for y'all? Let me just change it to a bigger font. All right, let's scroll down and you should be able to see this. So this is what you have done. If you were to type this in, yeah, it will source the root folders, the OPT ROS noetic. And same thing over here in your workspace. Let's put it side by side. Can devel, and you have the setup.bash. Okay, you have the setup.bash as you can see over here. So you can just type in setup.bash and press enter. Now, any kind of a new packages that is inside your what do we call inside your this Catking workspace is going to be recognized by the ROS. Okay, so this is what you're going to do, but I do not recommend you to include this inside your bash RC, because in the future you are still going to like what I said just now, you are still going to have different kind of workspace for different kind of projects, because you don't want to mix everything up, and there are different kinds of library and packages for you for different projects. So that is why I won't be including the set.bash for Catking workspace inside of the bash RC. Okay. So far, any question, or did I went too fast? If I go too fast, please let me know. You can type in the chat box if it is if this folder is okay for you. Oh, Jilin, just now you got answer 2 folders created. Yeah. 2 folders. One is Hacking Workspace, another one is the source. Okay. So okay, for are you okay with the speed that I'm currently in? If it is okay, just type okay in the chat box. If I went too fast, just let me know. All right. Okay. Cool. All right. So let's clear things up a little bit. Just close the bash RC, everything. Just close this down. Okay, we have our clean workspace over here. You have an empty workspace called Hacking Workspace. Now let's proceed to the next stuff lah. Or over here they already show you lah. So you can see that you can source the devel setup bash and everything. Oh yeah, if you already source it, then you can go ahead and echo your ROS package. Oh, okay. $sign ROS package path. Okay. So now you can see there's a new things added inside your ROS package path. Okay, just now you only have this opt ROS noetic share, and now once you source the devel setup.bash, you should be seeing a new directory inside your ROS package that is included inside your ROS package path. Okay, so this basically what it means is that anything or any new packages that is inside this particular workspace is going to be recognized in the future when you run you use the command ROS run. Okay, so now let's go ahead and go back to the tutorial. And what's the next one? Let's see. The next one should be allows you to create your own ROS package. Okay, let's click on creating a ROS package. Now, okay, yesterday I did mention about this ROS package and ROS node and all that, right? So what's the big deal about ROS package? That you can see that inside of the general idea of the big picture of a ROS system, I did mention about ROS node, I did mention about ROS topic, the ROS message, and the ROS master, but I did not mention about the ROS package. That is because a ROS package basically is something that used to store your node. Okay, it is something that used to store your nodes. So, for example, let me show you the inside my workspace just now. So I have a source folder, and you can see that I have a few folders over here. So I created a new package called camera detect, and these are all the necessary files and folders and the code that is required for me to run my camera detect ROS node. Okay, so this is my Python code now, and I basically store all these stuff inside of a ROS package called camera detect. So if I were to go here and go ahead and just source no, go back, and if I will go to training devel setup.bash, and now if I were to ROS run and I type in camera detect, when I double tap, it should detect the camera detect. Okay, so let's see something else. Okay, now if I were to echo my ROS package path, you can see that I didn't include anything that is related to my training workspace or the Hacking workspace. So if I were to run ROS run, camera detect, if I double tap, nothing will happen. It cannot detect the package. It cannot detect anything. That is because I didn't source it. So that is why on this terminal, I already sourced it, and I can use the command ROS run, and it should be able to detect the camera detect package. And inside this package, I have two files. One is object tracker, one is detect folder, detect files. Both are independently executable program. Okay. Does anyone have any problem? Have any difficulties to understand what is independently executable program? If you don't understand, you can just raise your hand so that I can explain a bit more about what does it mean. All right, we have two person raised. I have a couple of person raise their hand. So an independently executable program is basically sort of like your software or any kind of your code that you can run it without how to say, it can run by itself. Okay, so you don't need to run an extra a program or anything uh, first before you can run that particular program. Let's say, for example, for this over here, I'm running the camera detect and detect.py. So he himself is a publisher. Okay, it himself is a publisher that publish a certain the data. Let's see over here. Let's echo the okay. Before I go there, you can see that I have ROS topic list. I should have a new topic over here, and if I were to echo it, nothing will happen until it runs. Give it some time, and it should be start running right now. Nah, no, okay, let's give it some time. Okay, all right, so you have a camera, you have everything, and it is starting to detect the scissors over here. And you can see that on that particular detect.py, it is publishing a certain data to the topic called object location. So if I move it to another part of the frame, let's say to the right part of the frame, it should be giving out another data, which is 1. And if I go to the left part of the frame, it should be giving me 2. Okay, so this is what happened here, is that this particular program over here, it can run without a subscriber. Nobody is subscribing to it, but it is running by itself. Okay, this is what we call as an independently executable program. Okay, independently executable program. Does that clear up uh, the less understanding? Jilin and just now. All right, sure. Okay, cool. So I'm glad that kind of explanation is good enough to let you understand. But yeah, great. Okay, so let's move on. Okay. Oh yeah, just now I didn't show. Okay, whatever. Um. Okay. Wow. Where was I just now? Okay. Independently executable program. Okay. So yeah. Uh. Right now we have the ROS package called camera detect, and I have a ROS node called detect.py, and if I double tap over here, it should be able to recognize it. Okay. So this is what we call as the ROS package. Why we should have a ROS package. So now let's go ahead and create our own ROS package. Okay. So as I said just now, we should put nope, not this one. let's clear up a little bit. Okay. So okay, before when we create a new ROS package, can anyone answer me that where should I create that particular folder? You can type in the chat box if you know the answer. Okay, so okay, as I under the directory of Cat King Workspace, yeah, it should be inside it, but there's more. you need to go into the source folder. Okay, as I mentioned just now, you can see that I have a workspace called training workspace, and I put my packages inside my source folder. So that is why we need to we need to cd into the source folder and create the package inside this directory. So let's now go ahead and copy the next command over here, which is catkin create package. Okay. If just so you know, if you were to uh, want to create or want to create a new package in the future, but you forgot about the command, you can always just type catkin, double tap. You can see all the list of special command that has a catkin in it. So you can see that we have the catkin create package command over here. So let's go ahead and paste it lah. Okay, so you are now from this command. Can anyone tell me that what will happen over here? What will happen? You can also cheat a little bit. You can refer to the ROS wiki and let me know what will happen if I were to press on enter. Anyone answer it? Don't worry. You can try it. There's no wrong answer. I mean, technically there is, but nobody will blame you. But it's always good to try. Okay. Anyone want to try? You create files. Okay. How about, is there any other question? Any other answer? If no, then we should proceed because we don't have much time. Okay. Thank you, Ricky, for the answer. Yeah, your answer is partially correct. So yeah, what it does over here is that you can well, the command is very self-explanatory. It allows you to create a new ROS package over here. And because this catkin create package is a very special command that allows you to do something. What is the something? Okay, so now what is happening here is that you will create a folder called a package folder called beginner tutorials. Okay, the name of it will be beginner tutorials, and there are certain things that is behind the command. But what are these? These are the dependencies that you are going to use inside your package. Okay, so before you create a new package, you need to know that what kind of dependency that is required inside your ROS package. So for example, for this particular example is that beginner tutorial, we are going to create the talker and listener on your own, as shown in yesterday, back yesterday. You can see there is a talker that is talking something, printing out something, and there's another program, independently executable program, that is listening to what the talker say. So yeah, throughout those programs, you need to make sure that uh, they have a dependency of standard message, ROS Pi, and ROS C++. Okay, so let's go ahead and press on enter. It should start to create everything, and if you go into that particular folder source, and you could see that you have a beginner tutorial inside here, and you have a bunch of files over here created automatically. And if you were to go and double click on your package.xml, this will actually store every information about your package. You can see your package name is beginner tutorial, your email, and all that. Just so all this is necessary. All of these are necessary. You can see that all your dependency are here, are listed over here. ROS CPP, ROS Pi, and standard message. Okay. So why do you need all this information or all these files? That is because, as I mentioned previously, what is the beauty of ROS is because you can reuse the code from another developers. So basically, if you were to publish your own ROS package in the future, then people can refer back to your package information so that they know, this package requires this kind of a dependency and all that things. Okay, this is to ease everyone else lah, as well as yourself. So let's go ahead and proceed with the next folder, with the next command. Okay, so over here we have the kicking mat and all that. Okay, nothing much over here. Basically, okay, never mind. Okay, okay. Just now you have just created your ROS package, right? So before your ROS package can be used, you will need to compile your package. Okay, you need to compile your workspace. So let's go back to Kicking Workspace. Then should type in Kicking Make again. Okay, make sure you are in the workspace directory instead of the source directory, and only you execute the command Kicking Make. Okay, so it should run and it should compile everything. It should recognize your beginner tutorial. Yeah, yeah. I shouldn't press on enter yet just now. Uh, just so you can know what's the difference before and after you Kicking Make. But whatever, we already done it. So just go into your source folder, and I think no need. Okay, no need. Okay, source folder and everything. The rest of it over here is basically explain what is going on lah. As I said just now, you have a special command called kicking create package, and your package name and all your dependencies over here. Okay, and every time you make any changes inside your workspace, okay, inside your workspace, if you make any changes, you should go ahead and kicking make your workspace again. You should compile it everything again and again. Every changes, including if you have changed in code for specifically for any code that is written in C++. Okay, so if you look at my workspace over here, training workspace, if I were to change any code inside here, because it is a Python code, so I don't need to kicking make again. But if my code was written in C++, then I would need to recompile again. Okay, because just now I said it was sort of like something like a CMake to you for kicking make lah. Okay. So far, is there any questions for the kicking make and all this ROS package? If no, you can type in the chat so we can proceed to the next part of it. So far, no. Okay. Okay, if you want to go through everything, you basically just explain what the hell is what the hell, why do you need the package.xml and all that lah. If you want to go through by yourself, feel free to go through with it lah. Okay, so but we're not going to go through with it all of it because I already explained why do you need those package.xml and why do you need to create a ROS package. Okay, cool. Now, okay, this is the fun part already. Let's go into how to create your own publisher. Okay, you can go through all this understanding of nodes, understanding of topics, understanding of services. I would say once you better go through after you master your topics and notes or your publisher and subscriber first. For services, you can leave it first. Okay, you can just skip all these and go straight to writing your simple publisher and subscriber for C++, or you can go through the Python one. So we are going to open up both of them. Okay, let's go ahead and take a look at the C++ version. So now on this page, if you were to observe it properly, you can see there are two parts. The first part is to write your own publisher node, and the second part will be writing your subscriber node. But both are in C++ for this particular page. For the second page, it should be in Python. Okay. So, okay, now why do I create? The reason why I open up both Python and C++ because I want to show you the beauty. Another beauty of ROS. Can anyone guess what I'm trying to show for this session? Can anyone just type in the chat or open up your mic if you have any idea or guess what we are trying to do right now for this session? why do I open up the C++ and the Python version? It's very straightforward. Maybe we can go with Amar. Oh, we have Andrew. Andrew have already answered it. Maybe someone else want to answer it as well. Yeah, Nick Way answer cross-platform. How about the others? Maybe you can give it a try. Why do I use C++ and Python and open up everything? Can work together because, yeah. Okay, cool. Okay, so yeah, we're just going to proceed to it. Yes, correct. All of you are correct because yes, one of the beauty of ROS is because you can communicate the code that was written in Python and C++ without changing the code or converting the code. For example, like just now, if you were to if you are curious that the code that is written in the Arduino, which in this in Arduino, so the code were actually written in C++. Okay, they were written in C++, and I have my AI written in Python. And just now, my AI was publishing the data to a specific ROS topic called object location. And my C++ code on my Arduino was actually subscribed to the object location ROS topic. So once it gets the message, then it will read lah. Okay, you would know that, okay, I should know that if the LED data is equals to 2, 0, or 1, then I will execute what? I will blink which LED. Very straightforward, very simple. If you are very familiar with Arduino already, then this should be easy, just a piece of cake for you. Okay, it's just a little bit different from the way you program it. Because usually when we were to write the code for Arduino, we put everything inside of a loop folder or in the loop function. But in this case, for ROS, we're just going to put in the not handle spins one. I'm going to go through this later. So for now, we're just going to go simple. But you can see that just now at the first example that I'll show you, that it is the communication between an AI code, independently executable program written in Python, and is communicating to a Arduino that is written in C++. Cool. All right, let's go through for the first one. For C++, let's make it a publisher, all right? So let's go ahead and enter. Oh my God, what a chaos. Okay, let's clear it out a little bit. Clean. Okay. So before you write your own your own ROS node, let's just cd into your package that you want to store your nodes. Okay, if you look at the website, right, you can see that we have ROS CD. But what's ROS? What's the big deal about ROS CD? Right? We already have our own very traditional CD. Then we can go into the beginner tutorial source. We can go into the beginner and all sorts of place. But what's the big deal about ROS CD? Can anyone type in the chat box or guess what is the big deal about ROS CD? Can anyone try it? CD into ROS package directly. It straight away goes to the main ROS folder. Okay, cool. I think Ricky and Andrew are very active. Maybe some of you, if you didn't try to answer it, then you most likely will be left out through this training. So feel free to try it, or if not, I will be calling you myself. Okay, so okay, let's correct. Yeah, okay. Let's go back to the questions. And as mentioned by Andrew and Ricky, yes, both of them are correct. So the big deal about ROS CD is that, okay, now let's compare about CD. Okay, let me just clear it up. if I were to go into my ROS package or a particular directory or ROS directory or package, I need to cd into my source. I need to cd the beginner tutorial, everything. Then only I enter to the ROS package. But if I were to straight away just ROS cd and I didn't know where the hell is beginner tutorial, okay, let's say okay, I can ROS cd into the beginner tutorial if I remember the name lah, tutorials. Okay, so where what's wrong? What's wrong? Did I type something wrong? ROS cd beacon. Okay. I think I didn't source maybe. And then if I were to ROS cd into my beginner tutorial, yep, you can see that it recognized right away. And once I press enter, it saved me from some time to go for source, and then only I go into the beginner tutorial. Okay, so you see that, okay, this may be very simple and very you may see that things that, oh, this is something convenient but not very helpful. Now you remember that previously when you echo your ROS packages, you can see that you have a few directory. Let's, for example, the one that is inside your opt ROS noetic share, but you don't know if you don't want to go into the opt ROS noetic share. Then only you go and find the name of your particular package that is stored inside this directory. So this is why you can go ahead and just ROS cd. If I were to search for a package called the ROS C++, okay, C++. Now, if I press enter, straight away it will just bring me there. I don't need to go to like cd's root and then go and cd opt or ROS tap, and then go and find, oh my god, I have like share maybe, and then tap, and then I have 236 possibility. Now I press yes. Oh my god, it is a chaos if you were to search like this. So this is why it is highly recommend you use the ROS cd and just go ahead and straight away ROS cd beginner tutorial, press enter, boom, you are there. Okay, pretty fast, something that saves some times. Okay, so cool. Okay, now let's if you are already inside the beginner tutorial, now let's go into your source folder. Go into your source folder and you can see nothing is inside. Okay, there's nothing. Now, if you were to create a text folder in Linux, you can just, for graphical user interface, you can always go into this, use your mouse and create a new folder, a new files and all that. And or even you can just go ahead and maybe text or something like that, text editor. You can type your code over here, or if you have any preferred IDE or script writer or whatnot, like Visual Studio Code, go ahead and use it. You can always use it, but I prefer just write it on the text. And but you may be wonder, okay, that's cool if I have the access or the luxury to use all this graphical user interface inside my Ubuntu desktop. But how do you create and write a new files if you were to in a Ubuntu server where you don't even have the luxury of using a mouse? All you have is keyboard and terminal. That's it. But how do you write a code? Okay, now let me introduce you to nano, which is another very useful command that you can use. Okay, so now let's type in. Let me just enlarge everything. I'll just clear. Okay, now let's type in nano, and now I'm going to create a new folder where let's see what the I'm just going to call it Talker C++ lah, huh? Okay, call it talker.cpp. This is what it does is create a new file called talker, and it is a C++ file, C++ code. Now press enter. Your terminal suddenly will change. Okay, this is the interface that you will have in order to write your code. Okay, you can always write your code like this. You can just import everything or something like that. Okay, or maybe in C++ you are most likely to be using include, and yeah, you can see that straight away you have something to do with it. So you have maybe ROS C++, maybe something like that. Okay, so you can type your code with this interface. Once you are done, you can always just let me just type in something lah. Okay, include, I don't know, like ROS C++ or something like that. Okay, so if I want to save, I will press Control O. O for orange. Control O. Once you press Control O, press Enter, and then you want to exit it. Control X for X-ray. X for X-ray. Okay. So now let's go ahead and take a look your files over here. You can just use your graphical interface. Yes, why not? Because you already have this luxury. So see, everything that you just typed in just now is saved inside the ROS, the Talker C++ files. Okay, or you can just straight away just type in over here lah. Since like you already have the luxury. Okay, so let's go ahead and okay, you have this Talker, you have this code over here that you can just straight away just copy, just toggle the line and copy everything, and we'll explain everything later. Just copy it out. This is just for the demo or the visualization or the learning purposes, so we're not going to typing everything ourselves. Okay, so this is once you have copy and paste it inside this Talker C++ files lah. So I'm pretty sure that they have a lot of explanation inside here already, but let's go through a little bit lah. What is happening over here? First of all, in every ROS node, you're going to need a library called ROS.h. Okay, ROS.h. This is a header file for ROS. Where you if you want to do something with ROS or communicate with the ROS topic, communicate with ROS master, you're going to need this library, and you're going to need to specify your ROS message. For this particular code, it is going to send a string message. So the type of the data will be in string. So that's why you include standard message string. Okay, you can always go to, you can, if you say that, oh, I get the standard message, but how do I know I have a string inside this standard message? So as I always say, ROS Wiki is always your friend. So just go to ROS Wiki and type in ROS message or standard message. You'll see a whole list of message type that you can use. You can use Boolean, byte, char, float, integer, and multi-array, and all sort of stuff. But in this case, it's going to use string. Okay. So far, can everyone follow? Oh, we have vi command. Yeah, vi command. Yeah, vi is another way as well. You can always do it with vi, but I'm more familiar with nano. But you can always go with vi also. So if you use it vi, it's also doing the same thing lah. Okay. So let's just exit it. Nope. Okay. I'm not very familiar with the VI lah. But if you are familiar with it, you can always you can always use it if you want. Okay. Oops. Let me just open up over here. Okay. So let me just I want to have the luxury of using the beginner. Oh, okay. I need to source. Whatever. Okay. So now we have inside the source folder and everything. Now, okay, let's go back to the code. Okay, so for ROS, okay, you can see that these are the very common things that you have stream and you have a main. You have a main function for every C++ code. You have all this stuff lah. And you can see over here you have a ROS, something that is related to ROS. This over here is to allow you to initialize before you use any parts of a ROS lah. Okay, this is to initialize it, and for every ROS communication inside of C++, you need a not handle. Let's because you see that this code is actually very how to say, hard to read because it has a lot of command over here. Let's take a look at the one that I've written in the Arduino code. So as usual, for C++ code, for ROS, for everything that is about ROS, you're going to need a ROS.h library. That's the first thing. Second thing, you're going to mention about what kind of message that you are going to use. And the third one is the not handle. You need the not handle to do everything for you. Okay, so you can see that the code over here is not very long, but it's also quite short as well. But the most important parts of this of your ROS node for a publisher, not only for publisher but for every kind of a ROS node, there are a few components, key components that are required inside of your code. There are just the three of these, and you need to mention whether you want to publish or subscribe, mention the topic that you want, and then inside of your main folder or setup folder, you're going to need to initialize it and mention what do you want the not handle to do. Like for example, in this case, I want the not handle to subscribe to my object location topic. Okay, I want it to do this, and inside of the loop, I'm just going to ask the not handle to repeat itself. Okay, so if we go back to the code, you can see there are a lot of stuff over here. You have a publisher. In this case, because this Docker is the publisher, so you have to mention that it is a publisher, and it is going to advertise inside using a standard message string, and inside of a topic called chatter. Okay, and you have this rate. This is not compulsory, but this is basically just to sort of you can just specify the the rate of publishing for this particular ROS node. Okay, because just now when you look at my Python code over here, you can see that it is keep publishing the data without with a certain rate. But if you didn't mention the rate, it is going to go as fast that it can be. It can publish. But if you mention it, then your data publishing will be more consistent. Okay, let's say you want it to be publishing maybe once every 5 seconds, or maybe even 10 times per second. So you can mention the rate in hertz inside of your code using the ROS rate. Okay, and over here is basically some of your normal C++ code. This one, it says the ROS is okay. It basically is mentioning that if the ROS is not cancelled, if you didn't interrupt your ROS, then it should be keep running your everything that is inside of your loop. So over here you can just mention that we have a string, and the string would be hello world, and all sorts of stuff like count plus plus and all that. I'm not going to go through everything because most of them are basically very basic C++ code. And you're going to assign the message inside of your message data and all that. And this is one of another important parts, which is to publish. You need to mention it, and as I said just now, you need to spin once and everything. So yeah, very simple C++ code. If you are very confused with the explanation that I have just now, don't worry. Because I get it just now when I explain it, I also a bit confused myself. But as I said, always ROS Wiki is always your best friend. You see, every single lines of code was explained under your code over here. So you can see that it explained every single thing over here. So don't worry, if you don't understand a lot of explanation that I mentioned just now, you can always go through here. Okay, so this is what this is how you create your own publisher over here. So you can always come back and refer. Now, for let's go ahead and create our own subscriber lah. For this part, let's just save it. Okay, let's save our code. Okay, can anyone tell me that what should I do when I save my code? Maybe we can go with Vikash, Vikash Harish Chandran. Vikash, are you there? Yes. Okay. So what should I do once I save my code, my C++ code? Once I save it, what should I do? The very next thing that I should do before I proceed to the next step. Execute? No, because it is a C++ code. So I write the code inside of my ROS package, and now I need to compile. Yeah, I need to compile. So how do I compile it? Is that I'm going to need to go back to my Catkin workspace directory and Catkin make. So yeah, because I have a new code inside of my in my ROS package, so I will need to run a ROS like a Catkin make so that it knows that, oh, we have something changed in the code. Okay, so let's go back to the CD beginner tutorial source. Okay, you can see that we have a Docker C++. Okay. Now, before we go into and create our subscriber, let's try to run it. Okay, let's try to run it. Let's ROS run Docker. But if you double tap it, when you run ROS run, right, when you double tap it, it doesn't recognize. Because ROS run needs to come with the package name. Package name, then you need to type in the Docker. C++. Okay. So now if I enter it, it cannot run. Why? Why it cannot run? Can anyone tell me? No worry, this one I think I haven't explained yet, but if anyone who is familiar, maybe you can try to answer it. Why I cannot execute the Docker C++ code? And what should I do? Because my Catkin make failed? No. My Catkin make worked just fine. Okay, just to make sure, let's go ahead and try again. Catkin make. It's still the same thing. No headers. No. Okay, I think we don't have much time. We only have 21 minutes yet. So I'm going to give the answer. That is because your, let's go back to the folder, beginner tutorial, source. Okay, now if you can see the color of the docker.c++, it is in white color. What does that mean is that it is not executable. Okay, it is not it is not an executable file. So what I'm going to do is that I need to use sudo chmod 666 docker. Okay, this line of code over here is basically give all the you can just ignore the 666 actually, because it doesn't need that much of a permission. So you can just press plus X. So what is happening here is that if I were to press enter, it's going to change this Docker C++ file program into an executable file. If I were to press enter, now let's see. Okay, let's key in the password first. Now let's see if I ls again, the Docker C++ become a green color file. Okay, this means that it is executable. Okay, so now let's go ahead and ROS run again and see what happened. Okay, it says no such file directory and all that things. Okay. Huh. Okay, interesting. An unaccepted token. There's something wrong inside the code, I think. Let's go back and see what happened. Let's copy it again, maybe. Oops. Let's just to make sure everything works fine from here. Double click. Just like all. Press enter. Save it. And let's can make. Let's source it again, is it? Maybe just to make sure. And let's ROS run beginner tutorial, Docker C++. And we still have the problem with it. Let's go ahead and try this. No. Let's check what's happening over here. So there could be the code has some problem with it. So it says on line 4 there is okay. Let's just delete all the stuff over here, unnecessary stuff. This is in line 5, line 7, line unexpected. What's this? Okay, let's go ahead and save it and try again. Oh, need to kick him back again. Source, devel, set the hash, run, beginner tutorial, and Docker C++. Okay, we have still some of the problem. Unexpected token. Let's see, what are the tokens? Is there near unexpected tokens here? Okay, I have all this stuff. I think they could have some problem with the code for this particular file. Okay, it's okay. It's okay. Let's try another place. Okay, let's see. Let's go ahead and make it. Maybe we'll make it instead of the talker. Let's make it a listener, a subscriber, and see. What a troublesome. Maybe something was wrong with it, but it's okay. Let's just save it. And let's change the name to listener. And let's make again. Okay, ROS run. Nope. ROS run beginner, listener. We still have problem. Okay, it's okay. I think it's the C++ something with the code lah. But we don't have much time to troubleshoot the code. But unfortunately we cannot go ahead and troubleshoot what the hell is happening over there. But it's okay. Let's go ahead with the Python, both with Python. But you get the idea lah. if you were to write a code in C++, it should be able to work if you don't have any syntax error. But apparently, the syntax that is copied straight away from the ROS Wiki website, there are some problem with it. But yeah. Anyway. Oh yeah. Why not? I just download it from here. Yeah, I could have just download it from here. Why do I need to type it? Ah, crap. Okay. Never mind. I can just download it from here. Never mind. Let's see. What can I can just download it. Cannot copy everything. Maybe let's try again. Paste it, save it, name it into a Docker. Okay, then I go back and Catkin. I have a good feeling about this but let's try. If I cannot, but well, just screw it. Let's go ahead and press enter. God damn it. Okay, never mind. Let's give up on that lah, because we don't have time to troubleshoot them already. But you get the idea. You can write your own C++ code, and all you need to do is to make sure that all these key components for ROS are inside your ROS publisher. Okay, you can go through over here and you can create it. And every time you just finish typing it your code, you should be catkin make. Okay. Now let's go ahead and just make it a Python file lah. Bit awkward, but whatever. Because Python's always works best for me. I don't know why, but don't ask me. Let's go ahead and delete that files. And I just going to ROS CD beginner inside my source folder. LS. Okay, nothing's over here. Nano. I'll call it a Docker.py. Now I'm going to paste it over here. Paste the code in, and Control-O, Control-X. Okay. So let's ls. You can see the Docker is in white color. So let's sudo chmod plus x means executable, and mention the name. So now when you ls, it should be in green color. So now let's go back to catkin just in case, and catkin make. Okay, and let's source it again. Setup.bash. Oops. Setup.bash. And now let's try to run it. Docker. Python. Okay, inside the file again. But don't worry. Docker. I just wanted to mention Python 3 because we are using Noetic. Okay, so let's try again. Yeah, thankfully it works. Okay, so okay, you may be wondering, just now I just changed something inside of the Docker code, right? I just add on a tree. So if I make any changes, I should catkin make before I execute, right? But I can still execute it because I without even catkin make. That is because it is a Python file instead of a C++ file. Okay. Remove the void function from the beginning. Oh yeah, sure. Yang Ming and Zhihao, thank you for the answer. Sorry, I think I missed out the messages now, but it's okay. We can try it later. Now we have a Docker written in Python. Let's give it another try lah. Okay, give it another chance. Okay, make it a subscriber in C++. Okay. Let's go ahead and copy the code. You should. Nah. Just this too much. Just copy everything, and let's create another file inside there. That's ROS CD inside our beginner tutorial. CD inside the source, and let's create a listener. .c++. Listener.c++. Press enter. Paste everything over here, and as what's suggested by Zihao, is to remove the void function from the beginning. That's right. Okay, the first one. Yeah. Okay, this is actually something that could be quite quite important, but not really need to. But that's just leave it there. Control O, Control X, and LS and C is white in the white color sudo chmod plus X listener cpp. So let's go back to our Catkin workspace and Catkin make and source it. Okay, let's try to ROS run beginner tutorial listener. Okay, let's try. Okay, maybe you can try this. Nope. Okay. C file. Okay. Oh, okay. These are the problems. I think. Maybe you can just give it last chance. I don't want to delete the copyright. Usually, I won't delete the copyright stuff because it will be just quite not very professional if you were to delete all the copyright stuff, because sometimes you want to give credit to the ones who write the code, but apparently those who write the code, there is some problem with the syntax, so whatever. So I'm doing them a favor lah. So let's just delete everything. But usually C++, those commented commented parts, they won't be executed, but apparently there is something about it. So let's make again. Source develop setup bash, and then we can just ROS run beginner tutorial and listener. Darn it. Anyway, I think something's wrong with the C++ on my computer or something like that.
Yeah, maybe you can remove the .cpp and try the command again.
I already tried to remove it because I didn't mention the listener inside my my CMake list or something like that, if I'm not mistaken. If I were to run like this, it is not an executable file, it says. So apparently I need to mention it is a CPP file.
Or maybe it's because the first function that you deleted just now, the callback function.
The callback function, right? This, I believe you were mentioning to this.
Yeah, this one.
Okay, let's try again. Give it a try. I personally don't think it's this part.
Yeah.
But something about, because it keeps saying that I can't have the bracket or something like that. Let's try it. Catkin make, and let's source setup bash and ROS run beginner tutorial, and we have a listener. Yeah. Something's wrong with the. It says the unexpected bracket apparently, but it's okay.
Yeah, and there's something. To run a CPP file, we doesn't need to mention the .cpp at the end.
Let's see, because if I okay, maybe I missed something. Maybe I missed something. Let's go ahead and go back to the C++ file publisher, and maybe we missed something over here. Let's take a look. What did I miss? These are executable, add executable. It's okay. It's okay. Now, since it's already 9:30, later we're going to go ahead and do the one that is inside the Arduino. So I'm pretty sure the one that is inside Arduino won't have any much of a trouble with the syntax and all that. But let's just move on to this because I don't want to stay over here for too long. As now we already have a talker, and let's create a publisher. By the way, thank you for the input. CMake this according. It's okay. It's okay. Maybe if you all have more times, it's always recommended for you to explore yourself, and maybe go through some of the stuff over here. Yeah, I think we need to build the nodes as well. But yeah, we need to build the stuff on C++. There are a few things that we need to do before we can execute them. Yeah, I think Andrew's answer is the right answer that we want to say lah. Just now is for subscriber. Oh, okay. 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 I think what Andrew says is correct. Maybe you can try it, but not at this time because now it's already at 9:30. Sorry for the bad planning. So let's go ahead with the Python. Okay. Thank you for the inputs and the answer. That is very kind of you all. Okay. Let's go ahead and go with the listener. Okay, we have a listener for Python code. Let's just go ahead with the Python. And let me just delete this one, maybe. And let's just cd beginner source and nano. I just create a listener.py. Okay, just paste it here and go on top of it. Run it in Python 3. Control O, enter, Control X. No need to king make. I can just straight away no. I need to sudo c make it an executable file. Listener.py, ROS run, a beginner tutorial, talker. Let's say. Let's start a listener first. Okay. Okay. Now there's nothing over here. That is because I don't have anyone that is talking. Okay, this is not a good place for me to run that. But let's go over here. Let's go over here. Let me just sort of create a new one so that it is much better. Okay, let's take a look over here. Let's go to ROS Workspace, and the first thing we need to do is source devel /setup bash, and should be good to go. Let's copy this, paste it over here. Cat source it, and let's run the beginner tutorial, a talker. And over here we can just ROS run beginner tutorial listener. Let's run the listener first. Nothing happened. So we can just go ahead and ROS topic list. We can see there is a chatter topic already because the listener, we already execute the listener. Let me just zoom in a little bit, make it bigger. Okay, so we have a chatter already because the listener already started the chatter topic. It is waiting and it is listening. That is why. Now go back to the independently executable file. This is because the listener himself is an independently executable file program. So without any talker, it is still running. Okay, so let's go ahead and ROS topic echo chatter. Or maybe we can also go with ROS topic and see the info of chatter. And we can see that for this topic, ROS topic, for this chatter topic, there is a listener who is a subscriber that is already listening. The first one is the listener that we have over here, and the second one that is this one, because we are running ROS topic echo. We are listening to it, but nothing is inside yet. So if we run the talker over here, it should start spamming everything, sending the data, and the ROS topic can hear everything, and so do your listener. Okay, so pretty straightforward. This is how you can create your own publisher and a subscriber. Okay. Okay. So, so far, is there any questions? So far, is there any question for up to this point? Sorry for that. We don't have any break for today's because it is a bit rushing if we were to go to Arduino, because there is a long way to go. Is there any question? If no, you can type in the chat. So just let me know that you don't have any questions. Okay, let's say no. Okay, cool. How about the others? Are you guys okay? Is it too much to digest, or do you lose some steps, or do you need any help? Yep, following. Great. Okay, then I think okay. Finally, the last 20 or 15 minutes, we are going to the session which is allows us to communicate with Arduino. Okay, cool. Let's cancel all of this. Cancel all of this. Let's close everything. Shut up. Let's just close everything. I'll just okay. So okay, the first thing. The reason how I the method how I will be able to use ROS to communicate with my ROS Arduino with my ROS is because I have installed the ROS library inside of my Arduino IDE. So how do you install it? Now, if you have the Arduino IDE, you can straight away go to your library, manage library, maybe manage libraries over here, or Control-Shift-L, or Control-Shift-I, sorry, and it should be greeted with this page, and it's very easy. You can just straight away go and search for ROS, or you can just type in the full name ROS serial, and it should be here anytime soon. Why is it like this? Okay, so I recommend you all to install the version 0.7.8 because it works for me. Then it probably works fine for your site, for on your site. If your site doesn't work, maybe you can downgrade the version to the exact version that I'm using right now. So you can just install it over here, and once you install it, you can just straight away and include the ROS.h. Okay, and once you have included, you can always come to Files, Examples, and scroll all the way down. You should see a ROS serial Arduino library. Okay, over here. And over here, you can see that you have a lot of examples over here. As you can see that my code over here is the blink example of ROS. So you can just open up the examples and click on the blink examples. Okay. It should open up a new folder, a new file, but apparently I didn't save this one. But this is the blink folder, the blink file lah. And you can see that there are, as I mentioned just now, there are a few key components that you should have inside of your node. The first thing will be the ROS library, the message that you are going to use, not handle, okay, and you're going to need to initialize it, and you need to mention who to subscribe. Ask the not handle to subscribe to who. And in your loop file, you just have to put in not handle spin once, and everything should be fine. And for subscriber, this is the format. Basically, you can just mention that ROS subscriber, it should subscribe to the type of message of your topic lah. First of all, can mention that because just now you already include it over here. Of course, if you want to include more, you can always go ahead and include the one that is suitable for your application lah. Maybe you are sending string, maybe you can always go for string. Okay, something like this. Okay, and here you can mention that what is the ROS topic for this particular node. Okay, in this case, I'm going to create a new ROS topic called object location, and I'm going to assign every data that is coming inside the ROS topic object location inside to a function called LED. Okay, then I'm going to mention what this function will do. So this function, LED function, will basically read the data inside of the ROS topic, and basically you can just fetch the data through like just like this. Okay, so I mentioned if the data is equals to 2, then I'll blink the LED that is connected to the pin number 8 to high, wait for 100 milliseconds, and switch it to low, and repeat again. So everything, this code, I think it will be very simple for you to read if you were to work constantly work with Arduino. Okay, this is basically how you can create a ROS node on your Arduino, and you can just upload it like normal. So how do you like okay, big deal, you already upload the code on your Arduino, but how do you make sure that it can communicate with the ROS, right? So there is a package that was done by an open source developer called ROS Serial, as just now. So you can just go ahead, Google it, ROS Serial. Go ahead, click on the first link, which is the ROS Wiki. And make sure that you are in the right distro. If you are using Melodic, click on Melodic. If you are using Noetic, click on Noetic. In our training, we are using Noetic, so just click on Noetic. And scroll all the way down. You should see a list of different types of ROS serial that are available for different kind of a board. You can use ROS serial in your Arduino, in your Windows machine, or your STM32, TNC board, and so on. But for our case, because we are running it on our computer, so we are going to use the ROS serial Python. Just click on this. It should direct you to a GitHub page or this new page. Okay, it's okay. Just go to the GitHub page over here. Over here, you have a link over here. Just click on it. It should bring you to a GitHub page. Okay, over here you have a bunch of different types of ROS serial, and in this case, you are going to just git clone it. Okay, you can copy the link. Go back to your terminal. Go into your ROS package. Just maybe you can just cd catkin source it first, setup.bash, and ROS cd, your beginner tutorial. This is inside your package, not inside your source, yeah? Because you need to go into it inside your source first. Then this is where you put your what we call the packages. Okay, so the package, no, you need to go back. Okay, this is another package already. So this is inside your Catkin Workspace source. Okay, let me just zoom in a little bit. Catkin Workspace source. Okay, so you're going to want to create a new package, but in this case, you don't need to use Catkin create and so on and so forth. You don't need to do that, but instead you're going to just go ahead and git clone and paste the link that you just copied just now. Okay, and press enter. It should be done like this. Okay, so now if you were to list down everything inside your Catkin Workspace source, you can see that there is a new package called ROS serial. So as always, if you have if you have something changes in your workspace or you have a new package, feel free to just go back to your Kacking workspace and Kacking Mac. Okay, very easy. It should take some time, but it's worth it and worth the wait lah. So let's wait for it. Wow, it's 9:57 already. It's 53 already. Just for a quick question, are you all okay to extend a little bit to maybe around 10:30? Sure. All right, great. How about the rest of it? Okay, cool. Okay, thank you for the add-ons times. Sorry for the delays lah. Okay, yeah, let's wait for the Kacking mix to be done. Once it is done, then you should be able to let's go ahead and source it again lah, just in case. Source devel setup.bash, and let's see what do we have here. Okay, we have the beginner. We have the ROS serial over here, and just now I said we are going to use ROS serial Python. Okay, inside the ROS serial Python, we have a couple of files, but the most important one is the serial node. Okay, now let's go ahead and try to run it. ROS run, ROS serial Python tap, and serial tap. Okay, over here you can actually, in this case, you can just straight away just press enter. But there are a few things that you need to mention about the parameters. Like for example, when you're using serial, you need to mention what kind of a port that you are communicating, and the second thing is the baud rate of the serial. So let's go back to ROS wiki, and you can see the ROS serial Python over here. Okay, there are two parameters that you can work with. The first one is the port. The second one is the baud rate. So you can just go ahead and copy. You can actually copy the entire command, but yeah, let's do that. Let's do that. Okay, copy the entire command, and let's try to run it. If I run it like this, it would show me error. Okay, it will show me error. That is because I don't have. I think let's go to the ROS CD, ROS series, ROS serial Python, and then I have the nodes over here. So okay, you can see that serial node is actually executable, but why can't I execute it? That is because now I have my Arduino connected to my computer, but currently it is not. It is connected to. At first, it was connected to my Windows side, because now we are using a virtual machine, a VMware virtual machine. So how do you connect your Arduino to your Ubuntu? Is that you can press on the top left corner, press on removable device, choose the USB port that you are using, that you are connecting to your Arduino. Let's do that. And before we can run everything still, let's go ahead and check something. This is something that I think is pretty cool that for you all to look at it. Let's go ahead and cd into the root dev, and we have the dev and c. Let's see what do we have here. Okay, so if you cd into your root device directory and you press L, you type ls, you list down everything that is available inside here. You see a list of port that you have, a list of device that you have over here. So you can see that we have a TTY USB 0 over here. Okay, this is basically indicating that your Arduino is this port over here. And how do you know? Because back in Windows, right, you could have just select the port to COM4 and you can just upload it right away. But for Ubuntu, in order to upload anything or receive anything from Arduino, you need to give permission to your port. So I'm going to go ahead and straight away and do sudo chmod and give every possible permission, 666. Okay, just now when we give the permission to execute, we type in +X. But in order to give all permission, we just type in 666, type in /dev/tty USB 0. Okay, what does this mean is that it is giving the TTY USB port full permission. Okay, everything, read or write, everything. So let's press enter. Type in our password. Okay, let's try again. CD. Wait. And let's catkin make just to be sure. Okay. And let's source it. Setup bash. Okay. So let's run. Oh wait, I think I have a conflict also. Let me check something. Okay, I have a conflict over here. So let me just close down this part of it, because just now I have another workspace that already have the ROS serial, which is the training workspace over here. Okay, so from over here you can see that I already have the ROS serial. That's why just now it has some conflicts over here. So let's go ahead and see what do we have here in the new terminal over here. Okay, so we don't have the training workspace. So now we only need the catking workspace. So now let's source it here. Okay. And let's try to run the ROS serial again. Python serial node. Okay. Now let's go ahead and mention the port that we are using. The port was dev TTY USB 0, and the port will be the baud rate. The baud rate will be, let's see over here. So over here we didn't mention the baud rate, so it probably using the default baud rate that is mentioned inside of the library. Let's go ahead and do that. Let's see inside the Arduino libraries, and we have the ROS serial. Don't worry, this part you don't need to follow along, but you can, if in case in the future you are having some problems or anything, you can always go to your document Arduino and check out your libraries over here, and try to check what baud rate is it using. Okay, in my case, my default baud rate is 57600. So let's go ahead and type it inside here. 57600. Okay. Now if I press on enter, it should be, what's this? Do I have something wrong? Okay, let me just unplug it and try it again. Plug it in again. Should have this, and I should give the permission. Let's try it again. Oh, this is not a good day for me. Okay, it's okay. I think I could have a sort of like a conflict or something with my workspace. Create workspace and all that. Okay, it's okay. Let me just delete the one that is in my catking workspace. But I'm still going to run it this way. Let's catking back again because I delete something. Source, eval, /setup.bash. So crap. Let me just so if I run ROS serial. Okay. Oh, okay, I see. There could be the problem of because I don't have a ROS serial or something like that. Sudo apt install serial pi. Is it serial pi? Let me just search. Install Python serial. Yes. Okay, I already have. Okay, I think for Arduino now it's already 10. How about if I were to create another video so that I can show it properly to y'all, so that because now we are having a real time bugs that we're having here. So what do you guys think? Are you guys okay with that? And a lot of people already quit actually. Okay. How about the rest of it? The rest of you? Sure. All right. Okay. But actually, yeah, if I it's always a bad idea to demo it in real time actually, but you can always go ahead and if you wonder, you can always go ahead and go ahead and search for YouTube. You can go and maybe you can go ROS serial Arduino. There are a lot of tutorials available online that you can follow. Like for example, for this one from Vaishvik Shajnyam. Yeah, in 5 minutes, he can show you how do you connect your Arduino with the ROS. Basically, it's the same thing, which is using the ROS serial. But if you want to wait for the one that is happening over here, you can also do it. I'll record the proper one for you. So if you want to follow along, you can follow that video also. So now it's already 10. My apologies that I'm so sorry that I cannot. We are facing a lot of bugs over here and there. Yeah, and it's already 10 p.m. So don't worry, I'm going to send you all to the video, the proper video that we are having for to connect your Arduino with your ROS, as well as your I don't know your AI maybe, and also I will also send you all to the GitHub repo that I'm going to create later, so that you all can do the same thing as I did just now for the AI to the Arduino. Okay, so is that all cool for you? Okay, sure. Thank you, Si Yuan. Share them on the Airost Facebook page. Yeah. Okay. So far, other than the ROS serial parts, because it is not very well explained, is there any other question that you all have still have before you end this session? Why do we need to compile every changes in C++ but not Python? That is a very good question. Well, I don't have a very good question, a very good answer for that, because that is more on the compilation or the build when you build a certain program of your software.
I think I can answer for this.
Yeah, Xian.
Because in programming language, basically we have two types. One we call it compiler language, if I'm not mistaken. Another one we call it interpreter language. C++ is known as compiler language, while Python is known as interpreter language. What's the difference? Is basically in C++, we were the compiler language work in this way. In C++, when we finish the code, we'll compile it to the machine language first. The machine language is basically a very low level language, so that it can execute faster. But while interpreter language is more like we are asking the machine straight away to look at the Python code and figure out what is this Python code trying to do. It's like I'm asking you to read a foreign text, and then not. But in C++, instead of I give you the foreign text, I give you a translation of the foreign text. Then you definitely can understand the foreign text better, right? Yeah. So C++, it basically compile the code into machine language, which the machine can understand better and faster, which often lead to compiler language has a faster execution time than Python, which also explain why C++ is always faster than Python. Yeah. I hope that answer you. You can check more on the compiler and also the interpreter language thing on Google. Yeah.
Yeah, thank you, Xian, for helping to answer that questions. Other than that questions, is there any more specific questions for ROS? Which kind of project can a newbie to start off? Liang Ming, do you mean for ROS or just some general project? Is it? Oh, for ROS. Okay, so for ROS, I would say that you can start off by just go through the ROS tutorial that is inside the ROS wiki. As I mentioned previously, ROS wiki is always your friend. You can always go through over there. But once you go through on all of those things, it's always recommended. Not actually, if you can go to this. There is a page called there is a thing called the Turtlebot. Can go here, go their page, and you can follow along with this Turtlebot examples or the quick start guide. Okay, you can just do a lot. I think you can go for simulation. Okay, go for simulation, and this is actually a simulated robot that you can run on your Linux machine, and then everything you can have this Turtlebot. This Turtlebot is actually equipped with the ROS software running on it already, so you can do a lot of very cool stuff with ROS using this simulation, and you can learn pretty much a lot of things. Either it is from ROS perspective or a normal robot. So from here, you can learn a lot about robot without actually building a physical robot. So yeah, over here, I believe you can do a lot of stuff like G mapping. Like for example, you have this physical simulated world, and then you have the robot running on ROS, and you can map out the simulated world around you. And this kind of a mapping, right? You can do it in real life on your physical robot if you have the LiDAR sensor. And you can also do something very cool stuff like navigation, autonomous navigation. So over here, you can just use your mouse, click on somewhere inside the map. The robot will automatically create or plan a path in order to go to that particular goal that you just set just now using your mouse, which is very cool because imagine that you have a physical robot that you can do the same thing. Yeah, you can click on your screen and the robot will physically go to that particular place if you have the robot like that. Okay, So, and this kind of robot is possible for you to build on Arduino. That's the best part of it. So I would recommend after you go through the ROS Wiki tutorial, you can feel free to go to this Turtlebot page and go through this tutorial as well, so that you know the amazing stuff that the ROS can do to your robot. The third part is you can always you can come back to the ROS serial, where you can start to communicate ROS with your Arduino. Okay, and because on the Arduino you can build pretty much every kinds of robots that you want to build, where you can connect the motor drivers and all that kind of stuff onto your Arduino. And because of that, you can build a normal robot, a normal differential drive robot. Differential drive robot is something like this. Differential robot, which is a robot that has two wheels like this, so it can turn at the center of itself, or even travel forward, backward, and so on and so forth. So you can create a robot like this on yourself with an Arduino. Then you can invest a single board computer like Raspberry Pi, or just now if you have a bigger budget. But usually Raspberry Pi is the one that we will go through because it is much more I would say friendly, or the budget is much more friendly lah. Okay, so it won't break your wallet lah, because it's usually around 300 to 200 or something like that. So yeah, you can run ROS on here, because this is basically just a computer that you can run Ubuntu on it. And when you can run Ubuntu, you can run ROS on it. And once everything done, you can just attach the Raspberry Pi onto your robot that you just built with Arduino, and everything is unlimited. You can just create everything. You can buy more complex sensors and all that things to do a lot of stuff over here. Yeah, I think that will be the recommended roadmap for you to explore if you want to create a robot out of ROS. Yeah. Let me just show you this. Remember this diagram over here? Okay, remember this diagram over here that we have over here. You have an Arduino, and you have a single board computer, and your Arduino is connected to the motor driver. The motor driver is controlling all the 4 motors over here. And yeah, you can basically go crazy over here. You can either put camera, LiDAR, and all sorts of stuff over here. And for those who are in computer science, right, this is an additional information that I would like to share. If you say that, oh, if you're computer science, and how do you apply your skills that you learn in computer science onto ROS? Okay, there is a thing called the Robot Web Tools. Okay, Robot Web Tools. This page shows a lot of libraries and tools that allows you to communicate with ROS through your website in JavaScript. Cool, right? Because currently I'm also building one for myself. I'm building my own RVs. Okay, so yeah, you can see that there are a lot of library that you can use over here to communicate with ROS. Imagine that you have a web page. Okay, you have a web page full of your robot interface, and you can control it straight away from your website to your ROS robot. Unlimited, imagine it, unlimited potential, unlimited possibility. So for those who are in computer science, I hope this will help you somehow if you are into robotics. Yeah, I think that's pretty much it from me. Yeah. Okay, great. So how about is there any other questions before we end the session? Cool.
Cool. I think everyone, thanks for joining the workshop. I know that quite a lot of people has left a meeting, but I think it's still not too late for us to take a photo before we end the session, right?
Oh my god. The ending part is a bit chaos.
Yeah, I think it's okay. But I share a lot of interesting thing and useful thing for people who want to start robotics. I think that a lot of people who started, electronic engineering, mechatronic, or computer science, one of their, the reason to start this course are because they want to build a robot. Yeah, I believe it's one of the many reasons.
Yeah. Actually, if you learn ROS without a robot, usually that could be a very hard things for you because you don't really have a hands-on. So that is why you can go ahead and try it out on this Turtlebot. It's a free simulation software to allow you to test ROS without building a physical robot. Because if you were to build a physical robot, that is a budget to put in. Okay, that is quite a lot of budget. Yeah. So yeah, cool.
Okay, cool. So shall we proceed to the photography session?
Oh yeah, sure. Let me just connect my camera back to my Windows. Hopefully it won't bugged out. Yeah, thankfully. Okay, nice.
For others, maybe you can turn on your webcam, show us your beautiful smile, and
Let me just
then we can
unshare.
record down
Oh my
this
God.
moment.
So sad. Now it's already only have around 20.
It's okay. Okay, so maybe you can give other people a few more minutes so that they can take their time, turn on